Righty, it's Thursday, 4:55. Class just ended. Yours truly is going to go through the classwork pretty quickly. Remember, try to pick out one or two things each day that you want to concentrate on, or if you feel like you're making good gains just by repetitive practice, take that approach. Okay, so I'm going to do these problems out. Hopefully not make too many mistakes from fatigue. Question 1, sine of 11 pi over 6. Question 1, the sine of 11 pi over 6. All right, I know that 12 pi over 6 is over here. All right, you got 6 chunks of 6. Good drawings get good answers. So a chunk of 6, pi over 6, is a 30 degree. There's 3 there, 4, 5, 6, 7, 8, 9, 10, 11 is over here. Okay, and that's 30 degrees. What's opposite 30? Well, I got to draw the perpendicular. You're in the 4th quadrant, right? You're in the 4th quadrant, right, with an XY axis. So negative 1/2. So that's that altitude, negative 1/2. Okay, and if I was to draw, so I'm gonna layer these problems with a little bit of understanding, I hope. So here's the first period of the sine function. That's the 1st quadrant. That's the 2nd. That's the 3rd. You were in the 4th. You were here. This is negative 1, so that's negative 1/2. What created that? 330 degrees, which is what that is in degree measurement. 11 chunks of 30, 330. Okay, so that's where you would have been on the curve. All right, number 2. Number 2. Probably can't do that as much as I'd like because I'll never get out of here. Cosine, number 2, negative 17 pi over 3. Okay, I know that's close to negative 18 pi over 3. Negative 18 pi over 3 is minus 6 pi. So I'm going in this direction, that direction. And here's minus 18 pi over 3. Right, I'm going in this direction. So 1 less would be right about there. There's your triangle. Pi over 3 is a 60-degree reference angle. 60 degrees. And I'm looking for the cosine. Cosine is the width. What's that width? What quadrant am I in? 1st quadrant. Width is positive, positive 1/2. Okay, positive 1/2. I'm only going to do this one more time, and then I won't draw these again. One period of the cosine functions, cosine of 0 is 1, back to 1. You're in the 1st quad. Well, you're actually in a coterminal. You're actually way back here in a coterminal. But let's just look at 60 degrees. So 60 degrees is here. 60 degrees is maybe there. Minus 3 pi over 2. It's going to be a half. It's going to be a half. Yes, so 60 degrees is here. So you see the sign. That's right there. This is 1. Hopefully you can see that that's a half right there at 60 degrees. Okay? All right, took me a little while. A little fatigued here after a couple of classes, creating worksheets and everything else. Number 3, tangent of 23 pi over 4. The tangent of 23 pi over 4. 23 45-degree angles, right? Hopefully you're thinking 24 pi over 4, which is 6 pi. That's an even number of pi. That's 2 pi, 3 pi, 4 pi, 5 pi, 6 pi is right here. And I want to go 23, that's 1 less. And that's a 45-degree reference angle. So what are your heights and widths? They got to have something to do with root 2 over 2. Root 2 over 2, which is approximately 0.71, right? That's 1. I'm here. Tangent is what over what? Well, first off, I'm in the 4th quadrant, so what does that tell me my altitude is? My altitude's negative. So that's the opposite side divided by the adjacent. I like to think of it as height over width. I like to think of the tangent as the heights over the widths in the unit circle. That height over that width, when you divide negative root 2 over 2 by root 2 over 2, hopefully everybody can see that that is negative 1. Okay? Problem number 4, the sine of the arc cosine of negative 2/5. The sine of the arc cosine. The arc cosine is the top half of the circle. Now, if it's not one of my famous ratios, I like to think of the arc cosine as being drawn in either the 1st or 2nd quadrant. We have negative 2/5. We're doing the sine of the arc cosine of negative 2/5. That's a drawing. Okay, and that drawing looks something like this. -2 to 5. That's the drawing. And I need the sine, so I need that. So what's Pythagoras say? 25, 4, 25 minus 4 is 21. So what is this height? The square root of 21. Here's your reference angle. What is opposite that reference angle? Root 21 over 5. That is the opposite to hypotenuse ratio. We're not in a unit circle, so I don't want to make that a 1. Okay, I'm going to go by strict definition. Opposite, arc cosine, so this is width. This is the width divided by the hypotenuse, and we're after the what? The height divided by the hypotenuse. Okay, all right. Number 5, arc cosine of -1. Well, that's one of our famous ones. So where is width? -1. Arc cosine, or cosine inverse. I should read that as cosine inverse of -1. Well, that's +1. That's -1. How did I get there? 180 degrees. I give you a ratio. You give me an, I gave you a ratio. You give me an angle, because we're doing the inverse of the cosine 180 degrees, which is -1. That's angle to ratio. This language system is ratio to angle. Okay? I'm stressing that a lot more right now from the beginning of the semester, because students had trouble with that towards the end. I remember that happening last spring. So I'm starting to say that sooner in the semester. Give you a longer time to learn it. It's frustrating. I know it's frustrating how much material I'm giving you, but eventually the brakes are on and you get a chance to start the process. All right, I'm not grading you at all till midterm. Okay, so if you want to accelerate that, come to math help. Arc sine, sine inverse of -√3 over 2. Well, that's one of our famous ones. So I'm looking at the right-hand side of the circle. It's negative. Heights are positive in the first quadrant and negative in the negative first quadrant. What is -√3 over 2 as a decimal? Should be saying -0.87. So let me get a good circle. Boom. Let me erase this side because that pathway doesn't exist. That's 0 as a ratio gets me 0 degrees. What does -√3 over 2 look like? That's a good drawing. That's -√3 over 2. This is -1 down here. I'm getting close to that. So what do you think? What do you think that angle is? If you said -60 degrees, you would be right. If you said -π/3, you would even be better right. Because you usually just talk about, and what is -π/3? It's -3.14 divided by 3. That's a little bit more than one negative radius length. So here's a radius length. I'm going to go a little bit more than, I got to wrap it a little bit more. You can see it's certainly taking me down in this vicinity. This is real rough estimation here. Okay? All right, so that's problem number 4. Now you're going to try to solve a couple of trig equations. And you're going to be doing that on the fly because I haven't even done one. I've maybe done one with a couple of students in the room, but not many of you. So we're looking at, oh no, I'm looking at the wrong worksheet. Let me get that out of the way. That could be disastrous. Okay, those are all the correct problems. Now we're doing the smallest side of a 30, 60, 90 measures 7. That's 7. Here's your 30, 60, 90. That's 1/2. That's 1. That's √3 over 2. And I'm going to write √3 over 2 as 1/2 times √3 because that's going to be helpful. How does this number compare to that? I think 7 is 14 times the size of a half. So that's got to be 14 bigger. This is also a what kind of ratio? 30, 60, 90. Hypotenuse is twice the smallest side. So that's twice that. And how do I get to that? I multiply by 1.73 roughly. 1.73 times 0.5 is going to give me this. right? That's what that number is as a decimal. What do I multiply by here? 2. If I'm multiplying by a bigger number here, won't I get a little bit bigger side than this one? Hopefully so. Cut to the chase. 7 root 3. If you did Pythagorean theorem, that would be 7 root 3. So how do you get from the smallest to the middle? Multiply by root 3. How would you get from the middle back to the smallest? How would I go from there back? Divide by root 3. Big SAT question, often asked. Maybe not quite like that, but generally speaking, the study of trigonometry is every right triangle's got a particular ratio of this to that. Okay, and it's all stored in your calculator, except for the ones we're working with. Now we're doing algebra. So I'm going to do this quickly, telling you where I'm seeing mistakes. Number 8, 4x squared minus 8 equals 0. So 4x squared equals 8, x squared equals 2, x equals, a lot of you are forgetting to say plus or minus square root of 2. If you don't give me the plus minus, I don't give you one of those, because I don't know any other way to hold you accountable, or you'll keep making the mistake the whole semester. So try to remember plus minus. What is the square root of 2? You're supposed to know that. It's roughly 1.41. That's what we're using, 1.41, okay? And if I square 1.41, what should I get? I should get 2. All right, something close to it. Well, that's number 8. Number 9, 2/3 x minus 7 equals 5x over 2 minus 1. Now, if after you try this you get it wrong, in class you should be asking me to do 3 or 4 for you on the board. You try another 2, 3, or 4 to be able to get it right the next test. If you don't speak up, you're going to continue to get it wrong. So speak up. What gets rid of division by 3 and 2? Multiplication by 6. Multiply everything by 6. Now, 6 times 2 is 12, divided by 3 is 4. Would have been much easier to divide 3 into 6. 3 goes into 6, 2. 2 times 2 is 4. Minus 42 equals 15x minus 6. I like to make my x's positive, so that's 11x. Add 6 to this, gets you negative 36. Answer, negative 36 over 11. Next, graphing form, 10x squared minus 20x plus 7. 10x squared. I'm going to do it the quick way, and then I'll make sure that you can do it with minus b over 2a. 10x squared minus 20x plus 7. This is what I do, 17, excuse me. So I put the effort in to learn this. So I take the 10 out, positive, negative, so that's negative. 10 goes into 22, so that's going to be 1. 1 squared is 1 times 10 is 10. I'll get rid of that, and I'll add 17. All right? So obviously you would write positive 7 over here. Minus b over 2a. This is the way most people get it right. Positive 20 over 20. Well, that's 1. If that's 1, you're saying x minus 1 squared. And you're putting the 10 there because it's given. It's a gift. So take it. Then when you put 1 in, you get 10 minus 20 plus 17. That's 27 minus 20. 27 minus 7. 27 minus 20 is indeed 7. Either way, you do it some way that you get it right. Okay? Log base 2 of 116. So now I'm on problem 11. Problem 11. Log base 2 of 1 over 16. 1 over 16, 16 is 2 to the 4. Log base 2 is saying, hey, can you see something you're putting on top of 2? Yeah, I can see it's a 4. But where is it? It's not in the numerator. It's in the denominator. It's a reciprocal of this. So negative 4. And that's what's going on with that. Next problem. 2 times log base m to the 5 to get m to the 3. I'm sure this one threw you for loops, but you got to go back to basics. What is this asking? I'm going to do that last, right? What is this thing asking? What do you put on top of m to the 5th? And I'll put that what right there, right? Because, you know, it's going here. What do I put on top of this to get this? Obviously, power to power is multiplication. So I'm going to cut to the chase from now on, right there. If the bases are the same, then 5x equals 3. That has to be true. And x equals 3 over 5. Now, what is that 5? It's a fifth root. If you take the fifth root of m to the fifth, you got m. And if you cube it, you got m to the third. What am I going to do to this? I'm going to double it. I'm going to double that. So the final answer is 6/5. So this is 6/5. Okay? No, don't think I'm going to go anywhere else with that. No, so I probably gave you a lot of trouble in class, but we'll see. It does strengthen your understanding. Linear function. I like to write the coordinates in a table. Helps me. Well, I would just do this problem. Okay, so what's the first y I see? Well, let's get the 7 and the -2. So x plus 7, adding 7 gets, oh, is it -7? Did I copy it wrong? 7, -2, my mistake. So if I get rid of that number, I can bring the other one in. How did I get from -2 to 7? I went up 9. How did I change from 7 to 11? 4 units of change. Constant rate of change. That was problem number 13. Okay, so I guess we're going to do 14. Here we go. Repetition is my friend. I'm going to leave that there from now on, so I don't have to look at the sheet anymore. I'll get just a little bit quicker, which means I have a little more free time in my life. Now, quadratic, -3/6. Quadratic, I already know. X plus 3 squared plus 6. I already know that. Now I'm going to introduce the number 7. What's the change? The change in the parentheses is 10, but the squared change is 100. And I want to get to 201. How do you get from 6 to 201? Up 195. That's that function. Conjunction, junction, what's your function? Write the function whose endpoint is -3/5, so it's probably a square root, but let me look at the rest of it. That's problem 15. Look at how much time I saved. -3, pass it through 9,4. So I got to go through 9,4 from -3/5. Is it going up or down? It's going down. That's what it looks like. Square root function looks like that. What can I write inside the square root, which is like a grouping symbol? Well, I want to get rid of -3, so I write x plus 3. If I put in -3, I want 5, I better put it there. Get the marker. What is the change? Well, the change from -3 to 9 is a change of 12. But if that's inside a square root, then I've really changed by the square root of 12. I don't want that. I want to go from 5 to 4. -1. Okay? Going to start seeing these on your tests every day. Every single test. I forgot to put them on the last test because I just took something out of archives. But now that we're doing some trig, oh, I got so many more worksheets to work on. So now we're going to do ln of 8, number 16. Oh, I got rid of that. That was a mistake. ln of 16. I know what the ln of 2 is. 0.7. I know what the ln of 3 is. I think a 2 lives inside that number lots of times. I think it's 2 to the 4th. And what is 2? E to the 0.7. And what's the rule? Multiplication. So 2.8. 16 to the -3/2. Number 17. 17. 16 to the -3/2. I am going to do that. What's that ask me to do? Square root. I'm going to do that. 4 to the 3, 64. And what's that tell me to do? Reciprocate. So 1 over 64. That takes me to number 18. Number 18, x squared plus 20x. X squared plus 20x. So I know -10 is the x value of the center. Plus y squared minus 4y. I know that +2 is the center. Equals -4. If I add this up, I got 104. If I take away 104, I'm -104. If I take away, that's going to be 100. So I know my radius is 10. Okay? Now I'll do the problem out. What do you write? X plus 10 squared minus 100. And what do you write? y minus 2 squared minus 4 equals what? Negative 4. What do we do? Throw it over. Throw it over. What do we get? X plus 10 squared plus y minus 2 squared equals 100. What's the center of the circle? Negative 10, positive 2. What's the radius? 10. Name that tune. I got to make one. Okay, so it's on the video. Will I remember what I make? I doubt it. All right, let's start here. Let's say in the year 2000, 50 people were running around saying, when it's New Year's, the world's going to come to an end. The computers aren't going to work. That's a true story. Right? And then by the year, this makes no sense, 2007, we have 90 of something. Okay, so I don't know a realistic situation here unless I was doing temperature or something else. I'm just throwing some numbers your way. What's the most important number? I hope you said 70. I'm going to 50, going down 20. When we're working with maximums or minimums, it's nice to work with the cosine function because what's the cosine of 0? 1, it's the width, that's a max. If I did the minus, it would be a min. That's a min. 1 pi, 2 pi, 3 pi. In what? 2000 to 2007, 7 years, 1.5 revolutions, starting in the year 2000. Okay? We're going to build off of this. Going to get into some textbook problems. Approximate the sine of 6. The sine of 6. What does 6 represent? Doesn't have a degree symbol on it. So 6 is 6 radius lengths around a circle. Do you know how many radius lengths it takes to get to here? 3.14. There's one radius length, 2 radius lengths, 3. Right there, 3.14. So how many is it all the way around? 6.28 radius lengths. Doesn't matter the size of the circle. Whatever the radius is, multiply it by 6.28, and you got the circumference in decimal, approximation. Okay? I want 6. Let me be right about there, maybe. So what am I going to do? I'm going to draw the triangle. I'm going to go up. I don't know if you can tell from this, but doesn't that altitude look just about the same as the arc? So what do we think if we put in a calculator the sine of 6, we're going to get approximately what? Negative 0.28. Without a calculator, we know we're damn close. We're close. It's almost on top of the arc. Okay? And if you're out in the field, you're not working with pi, you're working with numbers like that. Because they're real nice on an x-axis. They work really well on an x-axis. Whereas whatever that degree measurement is, probably not very helpful. Okay? But 6 is something you can understand. 353 degrees, well, I don't know, we'd probably be close to, what do you think, as an angle? Let's see, I guess we'd have to have a conversion, right? I guess we'd have to multiply 6 times what? Pi into 180? Because this is radians, right? So if we did that, we'd find the angle. Not very helpful. All right, 18, I'm on 19. I'm gonna have to put this on YouTube and then load it up for you guys. 19, it's taking a while. Name that tune. Oh, that was 19. We're on 20. 20 is approximate value of sine of 6. We're on 21. Write the equation line that's perpendicular to 4x minus 5y equals, the constant does not matter. It's all about the rate of change, and the rate of change comes from dividing a coefficient of y to x. So we have a 4 to 5 rate of change. What's perpendicular to 4 to 5? Minus 5 to 4. As I said, it was always here to begin with. You can kind of see it. And passing through 7 up. So we got to get rid of the 7 in order to bring the up in. That's the perpendicular. Asymptote of 2. I'm just going to fly now. Okay, the old man's getting hungry. Asymptote of 2 through 812 and 1723. Through 812, 1723, right? Not drawn to scale, but it's definitely going up. So from 2 to 12 is a jump of 10. Next time, I'm not going to jump from 10. I'm going to go from 2 to 23. That's a jump of 21. So this is a little bit more than a doubling function. X equals 8, so I'm going to highlight the number 8. And from 8 to 17 is a jump of 9. That's that exponential function if you put it in Desmos. Remember, you can replay all these things as many times as you want. So I know I'm talking fast, but you can replay it, replay it, replay it. Okay, now we got a sinusoid. 2 sine x plus 1 equals 0. So therefore, the sine of x equals minus 1/2. You can think of it as the height in the unit circle is minus 1/2. So you make a unit circle. I know that height's 0. I know that height's minus 1. Looks like minus 1/2, right about there, right about there. If I connect it, geez, what does that look like? That looks like minus 1/2. I think that comes from 30-degree reference angle. Hang on. Hello. Oh, it's my son, Casey. Everybody say happy birthday to Casey. Oh, I'm making a video. They're going to see this tomorrow, and they're going to see me saying happy birthday to my son. You get to watch this. Yeah, I'm making a video for their homework. How about you call me back in 15 minutes? Yeah? All right, bye-bye. Where was I? Oh yeah, cut to the chase. This is 180 degrees. That's 210 degrees. That's 330. Okay, that's an angle. Excuse me. Something, I'm breathing in something here. Angle to ratio, what were the angles that work? 210 and 330. Oh boy, I hope I can keep going here. Got something in my throat. Another, name that tune. Another, name that tune. We're going to name this tune. We're going to go y equals 3. We're going to go growth. We're going to go the year 2000. Let's say we had 40. And in the year 2050, oh Christ, we got about 120. Okay, so what do we got? Everything's above 3. That number is 37 above 3. The next one, that's not 37 above 3. That's 117 above 3. This is a little bit more than tripling, I think. Maybe a little less. 3 times that, 90, 20. A little less than tripling, one or the other. X minus 2000 over 2050. So if I went from there to there, that's a change of 50 years. Okay? Now, what you want to do if you're not getting these is to really look at these numbers, look at the picture until you see where everything comes from. That's what you have to do. Okay? You can't abandon it. You got to say, where did that come from? Oh, here. Where'd that come from? Oh, that's that distance. So next time, let me find that distance. Oh, where did that come from? Oh, that differential. We call it a differential from the word difference. Okay, height of 9, height of 5. What's the difference from 9 to 5? 4. All right. Turning the page. Turning the page. Okay, I'm going to stick to this now. I really am going to just do the problem. Number 25. I got to get out of here. My kid's birthday, I got to call him. Log base 2, 2. Log base, let me take this right here. This will speed things up. X minus 3 over 2 plus 8. And I'm going to do, this is f of x, and I'm going to do f of 4. F of 4 means replace this with the number 4. 4 minus 3, I'm going to do this now with the eraser, is 1/2. What's the exponent you put on top of the 2 to get a 1/2? -1. 2 times -1 plus 8, f of 4 is 6. Number 26, speeding up here. X squared minus 12 equals 4x. Always set quadratics to 0. Hopefully you can factor. If not, we'll stop. 6 and 2 are 4 apart. Right? So 6 times 2 is 12. I want negative, so that's negative, that's positive. So yes, we could write that as a product. So why don't we? So x could equal 6, comma, negative 2. X squared minus 12 is a parabola dropped 12 units. 4x is a line that looks like that. That's intersecting up there at an x value of 6. This one's the negative 2. Yeah, trying to learn that too, right? I think around 27. Tan squared x equals 1. That's awful tough for how much you've been doing this. Very tough for how much you've been doing this. So x equals 1 or negative 1 equals 1. Okay, but tan is height over width. In order for height over width to equal 1, they got to be the same. So where's that going to be? Your 45s. Right? It's not going to be over here because that's a positive height. That's a negative width. So it's not going to be there. But it is going to be down here. Because that's a negative height and a negative width. When you divide a negative by a negative, you get a positive. So what is this? How much chunks have I got? 1, 2, 3, 4. So this is pi over 4. At 45 degrees, heights and widths are the same. And down here at 1, 2, 3, 4, 5 pi over 4. The tangent of that is also negative root 2 over 2 divided by negative root 2 over 2, right? Those are the famous ratios. Divide that, you get 1. So we're only going to be doing for one period. Okay, we'll look at general solutions later. All right, 2e to the x minus 4 minus 6 equals 0, number 28. 2e to the x minus 4 minus 6 equals 0. You're allowed to do this in my class, right? So what's the inverse of minus 6? Positive 6. What's the inverse of multiplication by 2? Division by 2. What's the inverse of e? ln. And x minus 4, add 4. 4 plus ln of 3. That's an exact answer. 5.1 is an approximate answer. Okay? I didn't see all of that. That's better position. Oh, I hope I didn't do that too often. 29. Getting there. Sine x minus 4, which is really height minus 4. You could have said height. Sine x minus 4. That's what I do. I do that. And 2 cosine x minus 1. 2 cosine x minus 1 equals 0. I write 2w minus 1 equals 0. So heights could equal 4. Where do you get an opposite to hypotenuse ratio of 4 to 1? You don't. If this number is bigger than 1, forget it. What's the width value? Width has to equal a half. Width is the x-axis. The x-axis goes from 0 to 1 to negative 1. Where's a half? Right there. How do I draw the triangles? Up and down and boom. Right? So there's a place here and a place there. Do you recognize the angle? I hope you say 60 degrees. Pretty good drawing. So one of your answers is 60 degrees. What's the cosine of 60? A half. 2 times a half is 1. 1 minus 1 is 0. 0 times anything is 0. The other one's down here. Well, that's 1 chunk of 3, 2 chunks of 3, 3 chunks of 3, 4. That's 5 chunks of 3. And the only way you're going to learn radian measurements is if I keep saying that. I know that's hard for you right now. Okay, brain's probably scrambled. Okay, talk about it, talk about it, talk about it. The longer we talk about it, the better chance you have of learning it. Okay, so we're going to keep doing it. That's why the scores were so low. Honestly, it's why your scores were so low at the start. If I gave you that first scrimmage on day 1, median would have been about 2. Right? And that doesn't mean you're not bright and you're not intellectual. I'm seeing a lot of bright kids in front of me, learning some things at a fast pace. Okay? But you got to have it in front of you, and you got to do it a long time, or you're not going to carry it into your next class. Here, Christ, I'm lecturing. Tell me to shut up. All right, slope-intercept form. Minus 3/7 x minus 4 minus 5. Oh, I'm getting tired. All right, minus 3/7 x Minus times a minus a plus. 3 times 4, 12 is being divided by 7. I'm going to multiply 7 times that. I get minus 35 over 7. I now have it. Minus 3/7 x. 12 minus 35 minus 23 over 7. I hope I'm not making careless errors because now I'm going to fly. All right. The inverse of 4 cosine x over 2 plus 3. The inverse of 4 cosine x over 2 plus 3. I hope I copied that right. The old man did. So that's y equals. So what do? Inverse. We make the y x. We make the x y. What's the inverse of addition of 3? Subtraction of 3. Boom. What's the inverse of multiplication by 4? Division by 4. Boom. What's the inverse of cosine? Arc cosine. This is now a ratio giving me this angle, y over 2. What's the inverse of division by 2? Multiplication by 2. And now I have a new function. That's the inverse of the original. Okay? We could check it with a number, but I'm tired. We'll do that another time. Okay? E to the minus 1.1, you're supposed to have this memorized. You have e to the 1.1 memorized. That's 3. So what's e to the minus 1.1? 1/3. That was number 32. I got to put these things on the board in case you're skipping around. 33. As a product, 7x squared plus 19x minus 6. As a product, 7x squared minus 19x plus 19x minus 6. Oh, God. Is that it? Yes. Well, start with what has to be true. 7x times x has to be true. There's only one combination for this. 1 and 2, or 1 and 6, sorry. 1 and 6, or 2 and 3. 6 times 7 is 42. I'm not putting a 6 here. 1 times 7 is 7, and 6 does not make 19. 3 times 7 is 21, and 2. Bingo. Positive, negative. Trial and error. 33. That was 33. 34. Cosine squared x minus cosine x. I'm being mean to you if I'm giving you this right away. Okay? This is a tough problem for you at this stage of your development. Okay? But I'm telling you, you can write cosine as what? W. So that's w squared minus w minus 2 equals 0. And remember what we want. What does x stand for with this language? We're looking for angles that give us the fractions that give us truth. Okay, so you got what? W minus 2 times w minus 1. When are your w's 2 in the unit circle? Never. Never above 1. So we're only looking for widths of 1. Where is a width of 1? Oh, 0 degrees. There's your answer. X could equal 0 degrees. Could also equal 2 pi, right? 0 pi. You know, but we usually just look at one revolution. And so when I give you this, that means the unit circle, and you don't have to duplicate. That's coterminal with that. So you don't have to duplicate that answer. Okay? Yeah, maybe I should have you duplicate it because one revolution is 0 to 2 pi. I am now changing. We're going to duplicate answers. So the answer to the last problem was 0 degrees or 360. Fill in a blank. X minus 5, x squared minus 4x plus 2. Okay, so x minus 5 times what gets me that? Well, I got to have an x. Minus 5 plus 1 makes minus 4. Minus 5 times 1 is minus 5. I'm trying to get to 2. I'm going to add 7 and express it fractionally like that. That tells me if I put a 5 in here, it better come out as positive 7. If I put a 5 in, I get 25 minus 20, which is 5, plus 2, positive 7. It's got to be right. 2x plus 3. Now, you haven't practiced this enough. I'm going to let you do the worksheet tomorrow, but we should do 5 or 6 of these in a row. We really need to do 5 or 6 of these in a row. That's an odd exponent. That's an odd exponent. That's for your benefit. Okay? Less than 0. So if I'm looking at this, I'm drawing a number line. I am looking at an odd exponent, so I know that I get a sign change here. If I put a positive 1 in, I get a positive. If I put a negative 1 in, I get a negative. That's a sign change occurring at the number 0. At 3, I do not get a sign change, so I like to use a dot. And at -4, I have a sign change, linear sign changes, okay? If I put a big number in, that's positive, that's positive, that's positive. You could put a false here, but I'm going to graph it. So that means that I'm headed north. No sign change. Sign change, sign change. That's what this graph looks like. That's a 4th degree parabola. 1, 3, 4. It's like a double parabola. When am I less than 0? -4 to 0. Right here. All these x's kick out what? Negative y value. So your answer is, you could write less than 0, greater than -4. That's the interval that solves that. If you're doing a sign chart, positive, 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 that's false. That's false, no sign change. Sign change, true. Sign change, false. All right. We got a good chunk. We got about 75% of the term in front of us. All right. Solve 3 ln of x minus 2 minus 3. 3 ln of x minus 2 minus 3. And this is problem number 37. Okay. And it equals 0. Okay, so what can I put there? -3 becomes +3. What can I do next? Divide by 3 becomes 1. Now I have the ln of x minus 2, right? So what is the base of this? It's really base e. We just don't write it. So what is the 1? It's what I put on top of e to get x minus 2. But since I'm doing inverses, I like to write it x minus 2 equals e to the 1. Most teachers would redo this and say, most teachers would definitely look at this and go, that's e to the 1 equals x minus 2. And there's nothing wrong with you doing it that way. But I'm trying to train your brain to do inverses, okay? So I'm going to leave the amount came from that exponential activity. So what's your answer? E plus 2, which is roughly 4.7. But that's an exact answer. All right, we're almost there. 45, 45, 90, and n. 45, 45, 90. There's 45, 45, 90. And if that's n, then that's n. And this is n root 2. In other words, n is getting multiplied by 1.41, approximately. Bigger, makes it bigger. Okay? Root 2 is what creates correlation between this side and this side. If I want to go from small to big, I multiply by root 2. If I want to go from big to small, I divide by 1.41. SAT question. All right, next question. Arc cosine of -1, I thought we already did it. Arc cosine of -1, I think we probably did the inverse, right? Which is the same as arc cosine, so that's 180 degrees. 180 degrees gets us a width of -1. Boy, I'm tired when I start drawing like that. All right, almost there. Simplify 1 minus sine squared x. Now this is new. Okay, so if that's 30 degrees, that's a half. Right? What's another way I could have written a half? Sine of 30 degrees. Right? With respect to what you're looking at here, let's say we don't know the angle. Then what is this? This is the height is the sine function. The width is the what? Cosine function. And that's 1. So what is 1 minus sine squared x? Cosine squared x. Okay? Let's actually see if that's true. Let's do a 3, 4, 5. Let's do a 3, 4, 5. 1 minus, what's sine squared? 4/5 squared. That's 1 minus 16 over 25. That's 25 over 25, which is equal to 9 over 25. What is the cosine? The cosine is 3/5. What is the square? 9 over 25. Oh, the same. So what is 1 minus sine squared x? This is sine squared x. This is cosine squared x. This is 1. What is 1 minus sine squared x? Cosine squared x. Another name for it. Boy, am I throwing you some stuff here. It's called, I don't even remember anymore, identity. Y equals -4. So we're going to graph -4, x minus 5, minus 6. We're going to graph that. A plus 6. All right, so 5, 6 is the vertex. Is this a V shape up or down? Down. What am I looking for? Y-intercept next, so I'm going to plug a 0 in, and that gives me -20 plus 6, -14. And 0 is to the left of 5. I'm done. You give me that, you know what you're looking at. 4 plus 10 e to the x minus 3. 4 plus 10 e to the x minus 3. 4 is the constant. That's our asymptote. E to the, we said it's best to do it as a 3-to-1 ratio. 3 to 1. When am I going to get a jump of 10? E to the 0 is 1. That's 1 jump to 10. So x equals 3. Gets me 10 units above 4. That's 14. Then I want to be 30 next if I can make this e to the 1.1. What makes that 1.1? 4.1. So 4.1 is the enter value, and that gives me e to the 1.1, which is 3. 3 times 10 is the 30, plus 4 is the 34. That's the process you want to learn. So look at that, replay this until you understand it. 1 period for 6 sine x plus 10. 6 sine x plus 10. So when you do a sinusoid, don't draw the x and y axis. We have a what? A positive sine function, starts in the middle. Okay, what is the middle? It's the constant, so that's 10. Up 6, 16, down 6, down to 4. What number do I want to start with? 0 gets me the start. 1 revolution later, 2 pi gets me back to 10. That must mean this is pi. That must mean this is pi over 2. Pi over 2 should get me 16. Let's at least see why. Sine of pi over 2. Pi over 2 is 90 degrees. 90 degrees right there. What's the height? A maximum. Height of 1. What's 1 times 6? 6 plus 10, 16. It does work. Last problem. How do you sketch 2 x minus 5 squared plus 19? What is the critical number? 5. Cup shape up. 5 gets you what? 0 plus 19 is 19. Where's the y-intercept? Left of 5 or right of 5? Left. Let's put a 0 in. 0 minus 5, -5 squared. 25 times 2, 50. 50 plus 19, 69. 0 gets you 69. So therefore, 10 also gets you 69. And how do you get the 2? Well, you look at 19 to 69. That's a jump of 50. 5 to 10 is a side length of 5, but an area of 25. What's 50 divided by 25? 2. So that's rise over run squared as measured from the vertex. And now I have to upload this, so I get to sit here for 10 minutes. I'll call my oldest son and give him a hard time. He's the coach of Deerfield now. He's got the Deerfield soccer team. Good luck, Case. All right, let me stop it, end the meeting.